So, good afternoon to everyone, and as you know, this is the first lecture for the course Quantitative Methods for Finance. I am the second teacher, Alessandro Ramponi, and you know that there are two main channels for this course, Channel A and Channel B. For this course, and the two channels will do exactly the same things. So the material of the course is shared with the other channel, and we try to proceed in the same way, and we share even the teaching assistants for this course, and so all the slides will be presented with a double name, but anyway, this is not so important. Okay. So what is this course? As you can imagine, from the title of the course, this is a applied mathematical course applied to financial and to the mathematical finance aspect of the financial instrument, to the study of financial instrument, and essentially we would like to introduce you with some analytical techniques. I'll tell you immediately what this means. Analytical technique for managing financial instruments and for apply the most commonly used techniques for what is called quantitative finance, okay? Which is related to risk management, asset pricing, portfolio management, and so on and so forth. We'll see in a moment some examples, but before doing some examples, I would like to explain how the course is organized. I know that this is important for you to know these points for this reason. So, the course is divided essentially into two parts. The first part is a review. For most of you is a review, but for other students, this can be the first time that they see the basic mathematics and statistics that is the basic mathematical and statistical instruments which are used for approaching and for working with financial instruments. So for working in mathematical finance framework. Okay? These basic mathematics and statistical instruments are the first, are the framework, the topics of the first part of the course. I want to stress this point since at the beginning of the course we will start with some very basic instruments, mathematical structures, which in principle have nothing to do with finance. Okay? And so this can be a bit discouraging for the student, since, well, I know we will talk at the beginning of the course from next week about matrices, determinants, solution of linear systems, and then multivariate calculus. This is the what I present to you in a moment. Then, after this first part of the course, the first more or less 5 weeks, we will start to work with some financial application. Not all, of course, but with some important basic financial applications. Okay, so the first part of the course is essentially devoted to a review, for most of you, of the basic mathematical structure, mathematical instruments that are typically used, that we will use for the second part of the course. Okay? So don't worry at the beginning if I talk about matrices, determinant, ranks, or derivatives, random variables, expectation, and some other things like this. But we will use all this instrument in the second part of the course. Okay? One of the characteristics of this course is that essentially the course is oriented, is programming oriented, in the sense that we will try, with the help of our teaching assistant, to introduce you to the fantastic world of Python programming. We will try to implement in Python, so all the things that we will do week by week in theory. So, no proofs, no theorems in general, but implementation, programming of this mathematical framework, mathematical instruments. Okay? This is one of the main characteristics of this course. So, well, this is the target that we have for you for at the end of the course. So the idea is that you must be able to formalize the problem, financial problem, in a proper way, to find the proper technique to solve the problem, and to program, to write the code for solving in practice this problem. Okay? The language, the programming language that we chose is Python, and which is, of course, is not the only programming language which is available for managing financial application, but is certainly one of the most famous and the most used all over the world. Okay, and another thing that is very important is that it is a freeware. It's for free, so you can download your version of Python in your laptop and work by yourself on your laptop. And this is what we will do. I want to the organization of the course. So in general, we will do every week. So the courses, we divide the course into weeks, as you will see. The first two lectures for our channel, the first two lectures will be theoretical lectures, so held by me, okay, with slides in which I will explain the mathematics and the financial problems and so on and so forth. On Friday, so we will have lectures on Monday from 6 to 8 p.m. That's the level. On Wednesday, this one, and then on Friday in the morning. Well, on Friday you will have the teaching assistant. Okay? So on Friday you have to bring with you your laptop, since the lectures will be practical lectures, in which the teaching assistant will explain you how to work on some problems. This week, how to download Python, the framework to use Python, and this kind, how to use basics about the Jupyter Notebook and this kind of things. And typically every Friday you will have a practical lecture. Okay? Sometimes, but this, you will have another practical lecture on Monday, but this will be not every week. Sometimes depends on the program. Okay? If we assume that you need to reinforce the Python skills, then we will schedule Python practical lectures on Monday, typically, okay, with the teaching assistant. Anyway. Some practical, before going to the example, some other practical news about the course. So you know the My Lewis learning platform. Not all you knows. No, maybe all of you know the My Lewis platform, but I saw that a few of you entered in the course. You can easily find course. In that in that platform, part of the platform for the devoted to the course, particularly Methods for Finance, I will upload every week the material of that week. So typically I will upload the slides, the theoretical slides, which are the core textbook for the exam, the core material for doing the exam. So the slides, okay, slides and all the explanation of the lecture that we will do week by week. And even the practical part. So we will give you some homeworks, the solution of the homeworks, some exercises, and even inform of Python codes. Okay? And I will upload the codes in the platform every week. Okay? Sometimes I forget. As you will see on Friday, you will use for implementing Python a framework which is called Anaconda. But on Friday you will see how to download, how to use it. One of the problems with Python is that since Python it's for free, it's software which is available to everyone. There are a lot of coding framework in which you can run your Python codes. Okay? So there are PyCharm, there are a lot of these. There is Anaconda, which we use it. So there is a Spider, there is Visual Studio, there is PyCharms, and so on. Okay? For some reasons, we decided to use the version of Python which is called the Jupyter Notebook, which is useful for didactical reasons. The idea is that you can run your program, you can write and run your program by using the browser. Okay? So Chrome, Firefox, Safari, whatever you want. You open the code with your browser, and then you have some cells. You write your code in cells, and you can run every cell with the command, and you can add comments to everything to every part of your code. Okay, so this is useful for commenting the code, so for didactical reason it's quite useful. But anyway, you can write your Python code even using other interpreters, so other softwares, and the output will be slightly, the way in which you see the code is slightly different, but the result is always the same. Okay, so we will use Jupyter Notebook. Okay. Who knows already Python? Who is able to program, to write in code in Python? Do you know other programming languages like wow,
No, I didn't.
Java?
I didn't high school. I don't remember much.
Okay.
Yeah.
MATLAB, R Studio.
Stata maybe.
Hmm?
Stata.
Yeah. Okay. Yeah. So. Just to before introducing with a motivating example, I you know that I would like to convince you that studying mathematics is useful, even for financial application. That's my job now. Okay. Before doing this, okay, I talked about the organization of the course. Week by week we will have some topics. I put the material of the topic week by week on the platform. We will have an intermediate exam and a final exam. So there are 2 exams for this year, which is slightly different from the last year. Okay. So we will have 2 exams, and more or less, well, the final exam is decided by the master, and for the intermediate exam, we will decide the date and moment depending on the material that we have until that. So more or less after 5 or 6 weeks, more or less, but we will talk about this later on during the course. The exam is divided into 2 parts. One, a theoretical part, which is something like answer to multiple choice questions or writing a few lines of calculations. And the second part of the exam will be a programming part. So we will ask you to produce some line of codes or read some line of codes and to produce this Python program, Python codes. Okay. The material of the course is what, so there is not, well, we gave some textbook, but mainly we will use the slides. Okay? The slides of the books that we will upload week by week. Okay. Okay. Just to give some motivation, some idea of what we will do during this exam, during this course. This is a typical problem in quantitative finance, and suppose that you have a set of financial instruments, which can be of different classes of instruments, and we'll see some of them during the second part of the course. And so you have these instruments in your portfolio, okay? And suppose that you want to measure the risk, whatever this means, of this portfolio, of your portfolio. So the first thing is that which are these financial instruments? So you know that there exists a lot of financial instruments of different kinds. So in the second part we will see some, not all of course, but only some of these instruments. Mainly we'll see equities, for example, and not from a financial point of view, but of instruments mainly. Okay, just since these are the two most important classes of instruments. We will not see derivatives or credit instruments, since derivatives and credit instruments are the core of some other courses that you will do during your master's. Okay, so we decided to not introduce the derivatives instruments. Okay? But suppose that you have given concepts and that your target is to measure the risk and, if possible, to reduce the risk. Okay, for your portfolio. So what we need to do? Well, the first thing is to introduce a measure of the risk and to quantify it. What does it mean, quantify? We would like to have a number which says what is the number, or a set of numbers which explain us, which says us what is how much is the risk, what is the risk of our portfolio. Okay? How can we do this? Well, typically this step is based on a particular topic, well, a particular area of mathematics, which is called probability and statistics. Probability and then statistics. Why? Well, essentially, whatever risk means, we would like to quantify what? Essentially, the possible loss of our portfolio, of our financial position. But possible loss means that we must model, in a sense, we must try to find a framework which describe us the possible future behavior of our financial instruments. Just for giving you an example, suppose that you have a fund, an ETF, for example, today, and then you have this, you would like to measure the risk of your position, so the risk of this fund, of having this fund in your portfolio for the next 6 months. Okay? So, what will be the value of this ETF, of this fund, in the next 6 months? Well, we don't know it. So, we have to use a mathematical framework to describe the possible future behavior of the value of the fund. So we need what is called a random variable. What is a random variable? A random variable is the possible realization, future realization of a quantity. In our case, the quantities will be the prices, the values of financial instruments. But this is probabilities much more general. Okay? So we will have to use probability and then statistics to introduce some quantities which describe in a synthetic way the behavior of these random variables. Okay? So probability and statistics are essentially a very useful framework, mathematical, rigorous and useful framework to model situation in which there is an uncertainty on what will we observe in the future, which is the world of finance. We don't know what will be the behavior of financial instruments. Otherwise, it would be very easy to manage a portfolio, but we don't know. And so we manage this the knowledge that we don't have, this uncertainty, by using a mathematical theory which is called probability. Probability helps us in describing situation in which we don't know what will be the value, the behavior of the quantity we are interested in. Okay? So we will describe the future behavior of prices and values of the financial instrument as random variables. Okay? From these random variables, which are models for describing uncertainty, from the characterization of this random variable, we will be able to extract some quantities which are useful for describing this behavior. So expectation, standard deviations, quantiles, probability distribution of functions, moments, and so on and so forth. Okay? And this is why probability and the statistical quantity that we typically we have at our disposal for studying a given problem will help us in this way. So typically the situation is, well, we will enter in these details later on in the course, but the situation is more or less the following. Today, I am interested in characterizing the risk or some characteristic of a financial instrument. I model this financial instrument by using random variables. I can look at the past data, the realized data, the past data which I observe. These are the database, like Refinitiv or Bloomberg or Yahoo Finance. These are the realization of our random variable in the past. By using past data and using statistical methods, I can guess what are the main characteristics for my random variable, which is the model for the future behavior of my instrument. Okay? So by using past data, I estimate the main quantities that I use for doing prediction for the future behavior of my the random variable which describe my financial instrument. Okay, this is why statistical methods, possibly with tons of data, which are now available quite easily at this moment. So we need the statistical technique which are able to manage tons of data. I extract information from the past. I model the random variables for describing my financial instrument, and then I can guess the future. Okay, this is why by using expectation, moments, quantiles, and so on. This is why probability and statistics are very important in the field of quantitative finance. And this is why we will study a bit of probability and statistics, at least the main definitions. We will not give you theorems or difficult calculations. We will only to give you some ideas, the basic properties, and the basic way to work with this very important mathematical instruments. Then, once we are able to characterize the behavior of the financial instruments, so for example the return of our fund, we need to measure the risk. So the idea is that typically we have to define a function which takes as input the characteristic of your financial instrument, of all the financial instruments in your portfolio, and then gives you a number which is a measure of the risk. There are many different functions which can measure risks. Do you know a measure of risk? What is the first measure of risk that you have in mind? Yeah, variance, standard deviation of variance. Other one? Quantiles, for example. Yeah, the beta.
L'ha scritto gruppo.
For example. Okay.
Questo qui.
What is clear is that once we have a given function which gives us a measure of risk, maybe you are understanding why this course is quantitative methods of finance. what does it mean, quantitative? Quantitative means that we need to end up our problem with a number. So we have to quantify something, in this case the risk. Okay? So, given our portfolio, we introduce a function which is a measure of the risk. For example, the variance of the portfolio, or the quantile, or some other quantity. This function will depend on what? This is a mathematical function, and so we will describe it as a mathematical function. So, from an input, we will have an output. Okay? The input of this function, what is? Well, the portfolio weights, how many shares of our equities we have for each equity, what is the exposition to one given instrument in our portfolio, and so the weights, and the properties of the asset, the expectation, the variances, the covariances, the covariations, and dispersion, and location and dispersion indexes, and other possible statistical quantities. So from this statistical, from the weights and the statistical quantities, we have an output, which is the risk, defined in some way. The easiest way that we can, maybe the most commonly used measure of risk is the variance of the portfolio. So you have the weights, you need the variance covariance matrix of your instrument, and then you compute the portfolio variance, which is a measure of the risk. We can discuss if this is a good measure of risk, but anyway, it's a measure of risk. Okay? So it's a function from the weights to a number. Okay? So it's a multivariate function. Okay? So in order to work with this objects in mathematics, we need the instrument of what is called the multivariate calculus. Multivariate calculus is calculus applied, developed for a function of more than one input, so multivariate function. There are a lot of things entering in multivariate calculus. Essentially, we need to use essentially derivatives, first and second derivatives. This is the most important quantities that we will use for multivariate calculus. Okay? Why this is important? Well, for example, we would like to know what happens if we increase the value of a position in our portfolio, so the weight of a position in our portfolio, and we would like to know if by increasing this value, so buying more equities for this share, if the risk increase or decrease. But how can we measure if we change the independent variable and the function will increase or decrease? What is the main mathematical quantity which help us in deciding this behavior? Derivative. Okay? If the derivative is positive, so the function is increasing. If the derivative is negative, the function is decreasing. For a univariate function, it's quite easy to understand. Maybe all of you have studied the basic calculus. For a multivariate function, it's slightly more tricky, and we will need a concept of partial derivatives. Partial first derivative, partial second derivatives. Okay? This is, well, the price to be paid for a more complex, more general function. Okay? So we need something about multivariate calculus. So the practice to implement this program is to download market data in form of arrays or matrices, and you will learn how to manage this point in Python. All for sure we will use the package in Python which is called the pandas data frame, which is devoted to the downloading and working with a large set of data frame. Then we have to extract from this data some information. Typically the data comes in the form of arrays, one-dimensional, two-dimensional, even more than one-dimensional array, and you must learn how to manage this in Python, of course. And then once we have all this information, we can implement the function, how to compute the command for the computation of the value of a function, whatever this function is defined. Just for give you an example, we will enter in these details later on. For example, in order to compute the portfolio variance, we have to compute a matrix, a square matrix. We will, the first set of lectures will be on matrices, and the symmetric matrix, and we have to compute what is called a quadratic form. So the matrix multiplication between vectors, matrix, and vectors. This is done quite easily in MATLAB, but in, sorry, not in MATLAB, in every programming language, but in particular in Python, and you will learn how to do it. Okay? This is the computation step. Then, one step further. Now we know what is the risk of our portfolio for the current weights. But we want to modify the weights of the portfolio in such a way to reduce the risk. It's possible to do this. Which kind of problem is this one? So this is entered in the class of what are called optimization problems. We have a function of more than one variable. Okay? In this case, the decision variables are the weight of the portfolio. Okay? Then we ask the question, can we modify the weights in such a way to reduce the risk? Possibly by introducing some constraints on the weights. Okay? Typically, we will see all these kind of things. This is essentially all the things that we will do during the course. Don't worry. But just to give you a motivation why we study Taylor expansion and optimization, Lagrangian methods for finding the constraint and minimization, for solving constraint and optimization problems, and so on and so forth. So you have the weights, which are our decision variables. Decision variables means that these are the variables that we can choose. So the manager can choose to sell a position or to buy more than what we currently have about the equity. And so these are the decision variables. How can we modify, how can we choose this variable in such a way to minimize the risk of our portfolio? So this kind of problem is what is called the portfolio allocation problem. Okay? And this is corresponds to a very important and used and studied problem, which is called optimization theory. Optimization means that we want to find the minimum or the maximum of something by choosing properly the variables. Okay? This is optimization. Typically, this is the framework of what is called the operational research. It's an entire framework of applied mathematics. The problem is quite complex in general, since we can introduce some constraints. For example, suppose that we operate operate in a market in which it's not possible to short selling the assets. I will explain. So short selling means that you sell the asset without any limit. Okay, you take the asset from a broker and then you sell, but then you have to give back the asset to the broker that sold you the asset. Okay, this is a procedure which sometimes is possible and some other times no. It's called a short sell. So the short selling corresponds to negative weights in portfolio. Okay? So if you operate in a market in which short selling is not permitted, you can constrain your weights, the weights of your portfolio, to be positive. They cannot be negative. Since negative weights means that you are short selling, and this is sometimes is not possible. So you have to introduce some constraints. Okay, so the general framework that we'll see is the constrained optimization. Okay, we will see just one example. The easiest example of constrained optimization. But this is a very important part of optimization theory. In some sense, everything which is applied mathematics is related to the constrained optimization. How can we realize this? The first thing is to define the function, the risk function, so the function which measures the risk of your portfolio. And then you have to use what is called the minimization algorithm. We will give you some general conditions for finding the minimum or maximum of a function, which is the theory. Okay? In most of the in some few cases, it is possible to do the calculation by hands if you are quite smart in mathematics. But except for very limited cases, we will optimize, we will find the minimum or the maximum of a multivariate function by using some algorithms. So some codes, some functions in Python, okay, which find, I will explain you how, the minimum, the constrained minimum or maximum of a given function. So typically the ingredients for doing this kind of program are two: the definition of the function and the minimization algorithm. Luckily enough, all these algorithms are implemented in Python. Okay? We have not to implement by ourselves the algorithm. These are some names of the most famous algorithms. Newton, Gradient is the most famous. Lemberg, Markov. We don't worry a lot about this. Okay? One of the reasons why the new generation of programming languages are so important and they are so used is that the basic ingredients are already implemented by someone else. So Python, as you will see, in Python, as you will see, at the beginning of every code, you have to import some libraries. Okay? The libraries contain a set of commands implementing something. Okay? For example, one of the most important libraries that we will use is NumPy. NumPy is a numerical Python. There is NumPy, there is SciPy, Pandas framework is another, Pandas data frame is another library, but we will use essentially NumPy for the numerical calculations. In the NumPy library, there are a lot of functions, many functions, for implementing all these kind of things. So matrix operations, function calculations, minimization algorithms, and a lot of this kind of things. Okay, this kind of numerical mathematics. What you will learn during this course is how to find the function that you need for solving a problem. That's our target. I will talk about ChatGPT in a moment. The last step, which is important for your course, is the analysis of the results obtained and the realization of tables, graphs, histogram, pie charts in order to learn how to introduce this quantitative answers into some presentation for your career. This could be important for your thesis, for example. If you will do a thesis which requires a programming part, then you can produce graphs, tables, some quantitative result to be presented to some. Okay? And okay, programming will be done in Python. We will use Python, and I already said that we will use Anaconda. Well, Anaconda is the framework. We will use Jupyter Notebook, and I want at this point talk about chat. ChatGPT exists. That's the fact. Okay? You can use it from your phone, from your cell, from your tablet, from your web. It exists. So, and it is very good. Python, among the things that you will know. Chat, among many things that can do, it's very good program. If you can try, if you give him, well, I treat him like a person, a program. So please write me a Python code for computing the covariance matrix of this set of observed returns, and then compute the covariance of the portfolio and minimize it by using the Levenberg-Marquardt algorithm. He will do exactly the code lines, the code for doing this. You can cut this program, copy on your Jupyter Notebook and run it. And 99.9% it's correct. Okay? So you can use it. The problem is that if you are not very expert in Python programming or in programming in general, it can happen that he sometimes do something which is not completely correct, and maybe you are not able to recognize it. Okay, so you have to check and check and check many times. What chat will do. But luckily enough, programming is something which is very practical. So you take the code, you try to use it. If it works, it works. You can stress the program to check if it's correct. And if it works, well, it works. Okay? But our idea is that, okay, you can use chat, of course, but you must be able, Python, yeah, it's wrong. Python is not written to refuse. You must be able to understand what he is doing. Okay? Most of the time he explains the line of codes, that especially in the very simple, some simple cases, he explains step by step. You can ask to explain step by step what he is doing. Okay? Another use of Python is that you can write your own code, give the code chat and ask if the code is correct or where is the error. Okay? And this is quite useful. Okay? Another way in which it's very useful, I use chat for doing this, if the following. Suppose that you want to produce a very special picture, a graph with inside another graph, which inside another graph. So if you want to do it by yourself, it's quite well, time wasting. So you have to look at some discussion forums and try. I use even MATLAB this. And well, the chat is very good in give you some suggestions for doing, if you are able to explicitly say what you want to do. So very precisely, you describe what you want to do very precisely, and most of the time he will give you the right answer. Sometimes it does not even work always, but you can adjust. You can discuss with it. Okay? During the exam, it will not possible to use chat. Okay? For studying, okay. Check if you are using chat, but if you are able to use it, okay? But the message is that you must be able to understand, completely understand what chat is saying to you. Okay? During the exam, it will not be possible to use chat. Okay? Okay, so description of the course in more details. So this is the first part of the course, and I want to stress that it's a course in which I will introduce you with some mathematical instruments. Most of these instruments are well known. Maybe all these things, maybe you have already studied these things during your bachelor degree. We will try to review this concept and to use a unified notation for working with these topics, with these mathematical instruments. So first week's about linear algebra. This means that we have to work with vector matrices, operation between vector and matrices, as we will see in a moment. Maybe. Matrices, rank, determinants, and the target will be solution of linear systems. This is a very general important part of linear algebra. And in our application, it will be important, since I would like to end this part of linear algebra by introducing with something which is called, maybe you know it, eigenvalues and eigenvectors. this instrument, these quantities, eigenvalues and eigenvectors, are related to the solution of some special linear systems that are very important in many applications. The following part of the course, for optimization and for some statistical procedures which are quite important. I don't know if you already know, for example, the principal component analysis, PCA. Never heard? Never? Principal component analysis. No, okay, we will do it. We will do it. And it's a very important technique in statistics, which is based on the notion of eigenvalues and eigenvector. Okay, this has very important application in finance. Then we will introduce this is not written, but the multivariate calculus, the main properties of a function of many variables. The most important result that we will use, which is used in finance, in quantitative finance for about multivariate calculus, is the Taylor expansion. You know Taylor expansion, so first, second derivatives. This can be generalized for multivariate function. And the Taylor expansion is quite important in finance, in quantitative finance. Then we'll see the optimization problems, which are divided into constrained and unconstrained optimization. So unconstrained is the easiest optimization that you can think about, and the constrained is a bit more tricky, and well, not just a bit, it's more. But we'll see one important technique, which is called the Lagrangian multiplier technique, for finding the constraint and the maximum or minimum of a multivariate function. I don't know if you have already studied, for example, the Markowitz portfolio allocation problem. From a mathematical point of view, is nothing but the application of the Lagrangian theory of constrained optimization. Nothing. So it's one result. Then an important part of this first part of the course is devoted to the probability theory. Since this is the part which is must be introduced carefully, and we will devote a couple of weeks for studying the basic of probability theory. So we have to introduce essentially random variables, expectation, moments, and covariances of random vectors, and probability distribution functions. Second part of the course, the more applied part. So this first part, well, it's mathematics. So, but I think that this is the necessary part, since without this mathematical structure, we cannot switch to the second part. Since all the problems that we'll see in the second part, they can be modeled, described, and solved. All the problems that we'll introduce can be solved using all the instruments of the first part. Okay? As in the example before. So, mean variance optimization and portfolio management, Markowitz. This is just only for introducing this problem, we need all the instruments that we introduced in the first part. So, notion of random variables, the return of the position in our portfolio are random variables characterized by a mean and a variance by given mean and variances. So we need to know how is defined the mean and the variance of a random variable. Then we have to introduce a measure of risk, which is a multivariate function of a particular form. And then we have to optimize this function. And this gives us the constrained optimization, and this will give us the well-known frontier, optimal frontier, okay, of the Markowitz optimization. Then we will give a look at the generalization of an improvement of the Markowitz portfolio homologation solution, which is called the Black-Litterman model. This is very used and very well known, and we will see how all these topics will have a practical part. So in the practical lecture, you will learn how to implement the optimal portfolio allocation, how to implement the Black-Litterman model. Okay, so just by using the views and so on and so forth. Then we'll see something about linear regression and principal component analysis. This is based on an application of some linear algebra results. This will be applied to a set of very important financial instruments that we will introduce during the week, which are the so-called fixed income instruments. Fixed income instruments are essentially bonds, coupon bonds, swaps, interest rate swaps, and we'll see these three basic instruments, okay? And which gives us a very important notion in the fixed income world, fixed income instrument, which is the term structure of interest rates. And we'll see how to apply the principal component analysis to some an application of principal component analysis to the analysis of the term structure of interest rates with implementation. Then, at the end, we'll see how to define some risk measures, like variance is one of the most commonly used risk measures, but there are some other some other types of measure for which are essentially, well, curiously enough, the name of this risk measure is the same of VAR. Variance is VAR, but VAR is value at risk, which is another kind of risk measure, which is quite important for many financial instruments. And we'll see how it's defined, how to compute it, and how to produce some so-called backtesting procedure for the risk management point of view. Okay, this is essentially a summary of what we will do in 12 week until the first week of December, if I remember well, or the last week of November, I don't remember. The last lecture is in December, first week of December. So we have to compute 12 week from now. Maybe we have to one lecture more, which is the lecture of yesterday, of Monday, which for some reasons in Lewis, the first day of the first week is devoted for the student of the first year, is devoted to the introduction to the rector, to the dean of the school, some so the lectures are suspended. Okay. Okay. So we have questions. No. Maybe it's a good idea to have a stop, to have a break, or 5 minutes. Then I will try to start with the first part.